Students to my channel Math Excellence. Today we are discussing another test which is F test. So in my last videos I have discussed with you that how to check on which problem how we can apply t test, z test and chi-square test. Like by looking the table how you can say yeah I have to go for t test, I have to go for z test. So all F conditions I have discussed. So now we are today starting with F test. In F-test class, F-test is used for comparing two variances from two populations. So what is the first thing in F-test? How many populations are required? Two population. First of all, not one population, two population. Second, what they're looking for? Two variances. So in any example, if you're seeing two populations we have, then one more thing, two population, we can go for Z and T also. But important thing is that when we are comparing the variances, then we always go for F test. And second, this is a formula for F statistic, sigma 1 square upon sigma 2 square. Sigma already I have discussed with you. This is a population variance. Okay, so sigma 1 square degree of freedom is n1 minus 1 because if we have two sample, obviously we have for the first sample size is n1, second sample size is n2. So what is degree of freedom? N1 minus 1, n2 minus 1. Okay, and sigma 1 square formula is n1 s1 square upon n1 minus 1. What is s1 square? You know that I have discussed in my first video. It's sample variance. And this one is also sample variance for second population. Okay. So F statistic is the formula when you will apply when you are comparing two variances. And how to calculate sigma 1 square? This is a formula. And X sigma 2, this is a formula. Okay, and please, little correction is required over here. It's sigma 2. Okay, not sigma 1. Please make a correction. It's sigma 2 square. Now, what are the process? Say, take H0, H1, check the critical value, apply the F test, and reject and accept the null hypothesis. These steps are similar in all the tests. Okay. Now, one important note we have, class. What is the formula I have discussed with you now? Sigma 1 square upon sigma 2 square. But every time you will not apply this formula. Why not now? First of all, class, they are saying if your sigma 1 square is greater than sigma 2 square, suppose you are calculating sigma 1 and sigma 2. Sigma 1 square is greater than sigma 2 square. Who is greater? Sigma 1, whatever the whichever the term is greater, that is always be in the numerator. Who is greater? Sigma 1, it is in the numerator. Apply this formula. But if sigma 2, please note it down this point, very important, but if sigma 2 is greater than sigma 1 square, then the formula is sigma 2 square upon sigma 1 square, which is in the numerator sigma 2 because it's greater. Why? Because f is always greater than 1. Keep remember, your f value should always greater than 1 and it will be greater than 1 only if in this scenario you are going accordingly. Otherwise, you are doing a mistake. So it's a very important. Now, already I have discussed if sigma 1 square is greater than sigma 2 square, go for this one. If sigma 2 square is greater than sigma 1 square, then this formula. If calculated value is less than table value, accept the hypothesis, otherwise reject. And this is a rise F test table. You will also sorry, this is a F test table. We always get this table in the exam. So here it's mentioned denominator, and here it's mentioned numerator. You can see on this vertical side they are giving me denominator, this one denominator, and they are giving numerator. Okay, depends. Sometimes here can be numerator, here can be denominator. So see very carefully, please. Okay, now let's start with the first example. What is the first example? How we can check we should go for which type of test? The standard deviations calculated from two random sample sizes 9 and 13. Now see, here they are saying first is 9, second sample size is 13. What are their standard deviations? Now, they are talking about standard deviations, so definitely we have to go for the F test, correct? May these samples be regarded as drawn from the normal population? You have to say that are these samples we are choosing from the normal population with same standard deviation or not? So what is your null hypothesis? Yes, you will say your two variances are same. Okay. In this question, are they using any word of greater, lesser? No. So sigma 1 square is not equals to sigma 2 square, correct? Now, what I need to calculate a formula, but very important, we have two formulas. Who will be the numerator? I don't know how to check by values of sigma 1 and sigma 2. So let's calculate sigma 1 square first. That is n1 s1 square upon n1 minus 1 put and calculate 9 2.1 square upon 9 minus 1, 8. So what is my sigma 1 square? My sigma 1 square after calculating is 4.96. Similarly, sigma 2 square n2 s2 square upon n2 minus 1. So this is 31.8 square. N2 minus 1 is 12. So the answer will be 3.51. So sigma 1 scale is this one. Sigma 2, who is greater? Sigma 1 scale is greater than sigma 2 scale. So what is the formula I will apply? Sigma. So who will be the numerator? Sigma 1. Sigma 1 square upon sigma 2 square. So value is 4.96 upon 3.51. My answer is 1.41, which is greater than 1. Now, see this carefully, please. N1 is 8, N2 is 13. So if N1 is, sorry, 9, not 8, N1 is 9, degree of freedom is 8. N2 is 13, degree of freedom is 12. But important point, we have to see who was in the numerator. Who was in the numerator? Sigma 1 was in the numerator because you have to see very carefully that whatever the term is numerator, we have to see over here. So numerator sigma 1, what is degree of freedom? 8. So where is 8? This one is 1 second. Let me do this. Okay. Where is 8? This one is 8 because I'm going for numerator. Now this is denominator 12. 12. So I have to check that. Okay, it's one picture only I have mentioned over here. It's okay, guys. You will get the table in your exam also. You can see after 9 there's a value of 10, 11, 12 also. Like now I'm just mentioning the value over here. So for my F test at 5% level of significance, 5% level of significance for 8 and 12 degree of freedom, table value is, I'm mentioning over here, table value is 2.85. So when we have calculated the value, so let me write the calculated value. So our calculated value was 1.41. Table value is 2.85. So my calculated is less than table value. So I have to accept the null hypothesis. Okay, and one more point, guys. In this table, actually, I have uploaded the picture, but it's showing till 9 degree of freedom. After this, we have 10, 11, 12, and the process is same. When you get 12, 12, and 8, what are the intersection value? That value is always your table value. Okay, so when you can download this table from the Google also. That is very easily available. In the examination also, usually you will get the table. So table value is given to you. Otherwise, if you will not get a table value, you can download from the internet and you can check in the same way, like 12 and 8. What is the cross section value? That will be your table value. So no need to worry about it. Okay. So in this way, you can apply the F test. And I'm going for the another example. Another example is Random samples are drawn from two populations, again two populations, and the following results were obtained. These are the values of first population, second population. Find the variance now. Two population is also given in t-test and z-test, but here they are saying variance. It means definitely I have to go for f-test. So take the null hypothesis, saying sigma x squared is equal to sigma y squared. I'm taking x and y because x and y are given to me. And h1 is sigma x squared is not equal to sigma y squared. So let's start to solve this question. X is given to me. So this x 16, 17, 18, 19, 20, 21, 22, 24. Solve this question with me, students, please. 6, 26, again 27. Again, I'm saying do not learn the table, learn the formula. I need to calculate sigma x squared. What is our formula? Already I have discussed 1 upon n1 minus 1. Okay, we have applied the formula sigma 1 square is n1 s1 square upon n1 minus 1. I'm not applying this formula. Why? Because is S1 is given? No, this is not given. So please do not apply this formula. You will go for the general formula that we have already discussed, okay, in the previous videos. So what is sigma x square formula? 1 upon n1 minus 1 xi minus x bar whole square. Okay? Apply this formula. So for this formula, what I need x bar. Do we have to calculate x bar because it's an individual series? So summation of x by n. We will get the values. So the sum of this one is 210. Total values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 210 by 10. So what is my x bar? My x bar is done. Okay, so I can calculate now xi minus x bar, and I can also calculate xi minus x bar whole square. So xi minus x bar 16 minus 10. So x bar is we are getting 21. It's minus 3. I have written 10. Make a correction. It's 21. So 16 minus 21, that is minus 5. 17 minus 21 minus 4. Minus 3, minus 2, minus 1, 0, 1, 3, 5, 6. Now, minus 5 square, 25, 16, 9, 4, 1, 0, 1, 9, 25, 36. Total is 126. So put the total over here. So when you are putting the total, that is 126, and n1 is 10, 10 minus 1, 9. So when you're solving, the answer is 14. So my sigma 1 square is 14. I'm writing here my sigma x square. I got 14. Done. Now similarly, guys, we got the idea. Now calculate y with me. Okay. What are the y values here? 19, 22, 23, 25, 26, 28. 29, 30, 31, 32, 35, 36. Total is 336. Okay. Calculate y bar similarly with me. Continuing over here to make it more easy. Y bar. How to calculate y bar? Summation y upon n. So individual series. This is 336 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So y bar when you are solving, you will get y bar as 28. So this is your y bar value. Now, what I need to calculate yi minus y bar, 19 minus 28, you will get minus 9, then minus 6, minus 5, minus 3, minus 2, 0, 1, 2, 3, 4, 7, and 8. Now yi minus y bar whole square, 981, 36, 9 square 81, 6 square 36, 125, 9, 4, 0, 1, 4, 9, 16, 49, and 64. So I think all of you have already written this one because I'm expecting that all the students are solving this question with me. Because if you're solving this question with me, so it's very easy, guys, for you to understand. Okay. So total is 298. Similarly, apply the formula sigma 2 square. This is 1 upon n2 minus 1 summation yi minus y whole square. This will be 11 and this is 298. So when you are solving it, you are getting 27.09. So what is sigma y square? 27.09. Now please see. What is sigma x square? This is 14. And what is sigma y square? 27.09. Who is greater? Sigma y square is greater than sigma x square. Who will win the numerator? Sigma y. Sigma y square upon sigma x square. 27.09 divided by 14. So keep remember who which is greater, that will be numerator. So my f is right now 1.9. Oh, we got the value. Now, who was in the numerator? You can see y now. So what is y? What is n2 value? 12. So how to check the degree of freedom? 12. 12 minus 1, 11. And for this one, so who is the numerator? Sigma 2. For this one, n1 was, we have said 10. So degree of freedom 9. So for this, stable value is 2.6458. Okay, this is stable value for this degree of freedom. So my calculated, this is my calculated. This is my tabulated. So you can see calculated value is less than tabulated value. I have to, one second guys. My calculated value is less than tabulated. I have to accept the null hypothesis. Again, I'm repeating a very important point. Why 11 is first, why 11 is in numerator reason, because sigma 2 square here is greater than sigma 1 square. That's why this comes first. So just keep remember this is very important point. Okay. So you can see from the table also. Now I'm discussing the last example, okay, which is again a different example because in first example I have discussed when sigma 1 is greater, how to solve. Second, when sigma 2 is greater. Correct? Now it's a different example how to solve this. In a laboratory experiment, two samples gave the following result. First, N1 is 10 and 2 is 12. Sample mean x1 bar is 15, x2 bar is 14. Always keep remember guys, always write the given things. Whatever is given, always write given. Question is very easy for us. Okay. Now, sum of square of deviation already I have discussed xi minus x bar whole square, which is 90. You can take if x by y also if you don't want to take x1, or you can simply take x and y. So what is second? Yi minus y bar whole square 108. All these things are given in the question, correct? Now, test the equality of sample variance. If they are saying test equality means variance are same. Variances are same means I have to go for F test. Okay, so let's start to solve this question. What is sigma 1 square? Need to calculate 1 upon n1 minus 1. I can apply this formula, but I'll not go. Why? Because this is not given to me. So I'll not go for this formula. Which formula I will apply? General formula xi minus x bar whole square. Okay, so what is n1 value? 10, 1 upon 9. And this is 90 given to me. Sigma 1 square, I'm getting 10. Now, sigma 2 square, 1 upon n2 minus 1 summation yi minus y bar whole square. N2 value is 12. So this is 11. This is 108. I'm getting 9.82. Now who is greater? Sigma 1 is greater. Sigma 1 square is greater than sigma 2 square. Apply the F statistic. Who is in the numerator? Sigma 1 square upon sigma 2 square. This is 10 upon 9.82. So value is 1.018. Done. So what is degree of freedom? and one is 10. So this is 9 into is 12. So this is 11. Sorry, degree of freedom, and table value is 2.90. So this is my calculated, this is my tabulated. Okay, students. Again, I'm repeating 9 is in the numerator. So in table, how to check numerator value? Here is 9. In denominator, I have 11. 11 denominator. So what is the intersection of these two values? That will be your table value. This one. Okay. Very easily you can see from table as well. Okay. So we have analyzed now my calculated value is less than tabulated value. So I have to accept the null hypothesis. So very easily you can solve these types of questions. Just please keep remember and check. When we are comparing the variances, I have to go always for F text. So very easily we can check it exam. Thank you, students.